Hello friends, welcome back to the YouTube channel Nitin Chandan Pure Water. In last session we talked about the point and non-point uh, sources of the water pollution and pathogens and its health hazards. Further extending to the sessions, we are talking biological oxygen demand and nutrient pollution. So, what is biological oxygen demand? Biological oxygen demand is nothing but the oxygen consumed by the bacteria during degradation of the organic compound. The organic compound, those are biologically degradable. So, these organic compounds are either converted into the carbon dioxide or it is converted into the methane gas. So, as per the reduction or the oxidation way and the cultures present there, but there is a consumption of the oxygen. So these bacteria consume the oxygen from the wastewater. So when there is a release of organic compound in the fresh water body, it starts by utilizing the bacteria from the ecosystem or the environment. It natural degradation happens and it reduces the oxygen of the fresh water. And low oxygen demand, low oxygen conditions is basically very harmful to the aquatic life, and it is including to the human life also. So what are the ways, what are the sources of these organic compounds and how does it enters? So there are the natural ways these organic compounds enter to the water body, like the leaf fall, vegetations, swamps. These are the natural sources. Human input plays big role because of the industry release, pulp and paper industries, food industries, wastewater. When it released to the freshwater body, it increases the organic component of the freshwater body. And packing industry, meat packing industry, if there is a when there is a wastewater treatment plant, so it is not treated properly, so it enters to the that organic compound enters the freshwater body and it starts to consume the oxygen. And non-point sources are like agriculture, farms, that is the one of the feedlots, that is the one of the source from where the organic compounds enters to the water body. We see how this dissolved oxygen level has impact on the water quality. So when dissolved oxygen level is concentration of dissolved oxygen in water is in the range of 8 to 9 ppm, we call it as a very good water. It's a fresh water. And then if it gets start to pollute, then the dissolved oxygen level started to decrease, so it depletes the dissolved oxygen level. So if slightly polluted, the dissolved oxygen level can reduce to the 6.7. Then moderately polluted water, we see the dissolved oxygen level decrease up to 4.5 to 6.7 milligram per liter. And heavily polluted water, less than 4.5 ppm dissolved oxygen level is reduced. And in case of when it get reduced to below 4, so it is very harmful for the aquatic life. Fish start to die at this condition. So we can see the how important this parameter of the dissolved oxygen in case of water, because it defines the presence of organic component and its tentative concentration, based on this dissolved oxygen. Because while determining also this BOD level, BOD conditions of the water, we have to first analyze the dissolved oxygen. So what is the dissolved oxygen present in the fresh water or the reference sample, and the water which one is polluted, what is the conditions of the dissolved oxygen in that water. So it is one of the analytical parameters. So further, if we go to the next level of the pollution, so that is the nutrient pollution. So nutrient, basically it is majority is the nitrogen and the phosphorus. We termed it as a nutrient because these two components are very much essential for the growth of the plants, animals, and everywhere. So these are the this plays a big role when it enters the water, because it starts to develop the it starts to develop life. So in presence of the sunlight, so like it enters in the water body through the fertilizer, farm, sewage, lawns. Those are the entry points of this nutrient, and it leads to the most important thing is that the presence of the nitrogen, phosphorus, large amount of this nutrient, it starts the eutrophication. So what is this? It is basically the formation of the start of the formation of the algal growth. So large amount of algae get forms in the water body. Sometimes it remains at the overall. We can see the large amount of water body is covered by the green color. So these are the algae, and this happens to the because of the eutrophication. So this actually leads to the it affects because it presents at the surface, top surface. It restricts the sunlight and the oxygen to enter in the water body. So this is also a harmful effect of the nutrient pollution. Now, the what are the solutions? So, how we can restrict the entry of this nutrient in water body? The first is the phosphate-free detergent. One is that we with the detergent which is being used a lot for washing, cleaning. That contains the phosphate. It is used. Phosphate is used to basically complex the calcium, hardness calcium and magnesium present in the water, so that the water can become smooth. And so to complex this calcium and magnesium, phosphate is heavily used in the detergent industry, and it is being released. Then it is released in the wastewater through the washing. Then so we can minimize, or we can avoid the use of this phosphate free detergent. We cannot avoid the detergent, but we have to find a way to utilize this detergent phosphate in the phosphate free form. Then another is the plantation vegetation. That is the because we know the plant also need this nutrient. So the more and more plant we can plantation is done, this can take up this nutrient from the water and utilize for its own growth. Then treatment of the proper treatment of the wastewater. So many times it happens that the only carbon is removed from the wastewater, and it is just released to the freshwater body. So carbon in the form of COD, POD is released up to the required level, and then it is released. So it's better that we also treat the nutrient, or even the better way to recover the nutrient from the wastewater, and then yeah, reuse it or recycle it. So that situations had slowly arriving that we can reuse this nutrient to maintain the circular economy, and reduce the fertilizer application. So right now the fertilizer which is being used is inorganic form. The phosphates are used, potassium phosphates, and the this phosphoric acid. So it is prepared by utilizing the utilization of the phosphate which is coming from the rock. So that can be avoided by using this organic phosphate. The recycled nutrients can be used. So in the fertilizer, so organic fertilizer, that is the common term it is called. So that is one of the solution for this. Next, we go to the nitrogen cycle. This is one of the important phenomenon in our ecosystem. So, as we know, nitrogen is present. Almost 78% nitrogen is present in our environment, in the air, and this nitrogen is being fixed by the nitrogen fixing bacteria. It is been taken up from the environment, and the naturally occurring bacteria fixes nitrogen, convert it into the NH3, so reduce it into the ammonia. So this ammonical nitrogen further get denitrified, nitrified by the nitrifying bacteria and converted into oxidized form. So oxidized NO3 is get assimilated by the plant, and it is being utilized for its growth, and some part is also converted into NO2. There is some ammonification happen through the whatever the feedstocks from the animals, so that ammonification is also happen, and it also convert into the NO2 by the oxidation. So after this, the oxidation of NO2 and NO3, this is there are the naturally occurring denitrifying bacteria, which converts this oxidized nitrogen into the nitrogen gas again. So it again releases to the environment. So this is how this nitrogen cycle work. So there is a role of the animal, plant, and the bacteria, soil, and the sunlight. So this is the pattern of the nitrogen cycle completion. So it's actually continuously happen in the natural way in the environment. So we'll just go little bit deep into the eutrophication. It is the process where water bodies get enriched excessively with the nutrients. This leads to the harmful algal blooms, oxygen depletion, and negative impact on the aquatic life. It's a serious environmental issue, so often driven human activities, because more contribution is through the human activities. So fertilizer runoff and the sewage discharge that plays a big role here. So we can see there how this nitrogen is being get added as shown in the picture here from the various sources: discharge of the untreated municipal sewage water, nitrogen compound produced by the factories, discharge of the treated municipal sewage. So sometimes it is not totally removed. So nitrogen and phosphorus remains in the even in the treated water. Then the dissolving nitrogen oxides from the internal combustions and the furnaces. So the factories, it releases the it releases use after burning of the coal. It releases the fumes. The fumes are then dissolved into the water, and it contains the nitrogen. So those get released to the body. A runoff of the erosion and that is again adds then runoff of the street. So this all adds to the lake or the ecosystem of freshwater body, and it leads to the eutrophication. So picture here, the how this eutrophication create a dead zone in water body. So the first one is that healthy water, where the sunlight is directly entering, oxygen is totally present, and mixing is happening properly. In another picture, because of the eutrophication, the whole surface is get covered by the algae, and there is a sunlight is being restricted, and we can see the aquatic life or the create and because of that dead zone is created, and aquatic life get dead there. So this is how the this impact on the of the eutrophication, which is it creates a harmful effect on the aquatic life and the environment, and also the environment, because it starts to create another cultures, and then insects, and then mosquitoes, which is again harmful for the human life also. Thanks for your attention. In the next session, we'll go further to the treatment of the wastewater. Thank you.